Good evening. Today we are going to be talking about conservation of linear momentum and then collision. Okay. Now, the conservation of linear momentum depends on the second law of Newton, the third law of Newton. I am sure that by now you know the two laws. Okay. The second law states that the rate of change of momentum is directly proportional to the force, and it is in the direction of the force. Okay. And then the third law states that for every action there is an equal and opposite reaction. Okay. Now, what is conservation of linear momentum? Conservation of linear momentum simply states that if two or more bodies collide, okay, the momentum is constant in an isolated system. Okay, all right. So if two or more bodies collide, okay, in an isolated system, the momentum is constant. It is constant. That is the conservation of linear momentum. Okay. Now, this brings us to collision. What is collision? Okay. Now, collision, we have two types of collision. Collision is simply collision. Okay, when two things collide is collision. Okay, what are the types of collision? We have what we call the elastic collision. We have what we call the elastic collision, and then we have what we call the inelastic collision. Okay, now in elastic collision, when two bodies collide, okay, they move with different velocity after collision. The two bodies move with different velocity after collision. That is for elastic collision. All right. Now in inelastic collision, on the other hand, okay, if two bodies collide, okay, the velocity, they move with the same velocity after collision. The velocity is the same after collision. Okay. Now for elastic collision and inelastic collision, the momentum doesn't change. But when it comes to the kinetic energy, the elastic collision, the Ke is doesn't change. The Ke doesn't change. But when it comes to inelastic collision, the Ke changes. Okay. Now you now agree with me that in elastic collision, all right, the kinetic energy doesn't change. All right. Now let's express the conservation of linear momentum mathematically. Okay. By now we know what momentum is. Momentum is simply the product of mass and velocity. So when we say momentum is conserved, when we say conservation of, when you hear conservation of linear momentum, it means that the momentum before collision is the same thing with the momentum after collision. Okay, that means mu plus mu is equal to mu plus mu, where u is velocity. Okay, so now if you have before collision, the momentum before collision, P rho is equal to mv. Okay, now we are looking at two bodies. It's not just a body, so it's not just mv, it's two bodies. So let's say this is one body, this is another body. This one is having its momentum. This one is having its momentum. Momentum is equal to mv. Momentum is equal to mv. So now if we want to find the momentum before collision for these two bodies, if you want to find the momentum for these two bodies, okay, it means we are going to sum the respective momentum of each body. So it means before collision, we will now say that we have if we are to call this one body 1 and this one body 2. So it means, or let me use A. The one that is common is A and B. So we have mass A, velocity A, mass B, velocity B. What this means is that the velocity of body A times the velocity of body A, mass of body B times velocity of body B. So if we want to find the total momentum before collision, it equals to what? MA VA plus what? MB VB. So this is what? Momentum before collision. This is the momentum before collision. So if we want to find after collision, so now if the two bodies, okay, after collision, they are moving now, okay, after collision, this is before collision, pardon me, okay. Now after collision, they are now moving together with the same velocity, it means that this one is going to be V, this one is going to be V, okay. The velocity is the same, so we are not going to be differentiating it. If V is 5 for this, it means V is going to be 5 for this one, because they are moving with the same velocity after collision. So it means that we have M, okay, A, V, okay. This one is for mass of A, okay, this is body A, this is body B, mass of A times its velocity, and then we have what? Plus what? Mass of B times its velocity. So this is the what? Momentum after collision. That's if the body is moving with the same velocity. But if they are not moving with the same velocity, it means that we are free. We can put A here. That means this one is having its own velocity, okay. Now this one will have its own velocity. So it means that the body will not be together. They won't move together again. They won't be moving together because it's no longer the same velocity. So you'll be having something like this, okay. Now if they are moving in the same direction, okay. But before I deviate, I am still talking about the conservation, writing the conservation law mathematically. So this is what we are going to use. So now if this is momentum before collision and this is momentum after collision, so the law of conservation of linear momentum says that the momentum before collision is equal to the momentum after collision. So we are going to equate before collision is equal to what? After collision. So before collision we have it to be what? M what? Sorry, MA VA plus what? MB VB is equal to what? MA VA, this one, plus what? MB VB. So this is the what? Mathematical expression for what? Conservation of linear momentum. Okay, now I want to talk about what if somebody is asking, what does this really make sense? Okay, when we're talking about a collision, you know this snooker ball, you know, I asked my student one time, what's the ball called? And they told me it's billiard. Can't remember. Billiard something. But please, I will use snooker balls. I hope you understand what I'm trying to say. Okay? You know, if you have observed where they are playing snooker, you know, okay, you will see a situation where a ball, okay, they use one ball to hit another ball. There are some situations where the two balls will move together, and there's another situation where one ball will hit the other and they will all move at separate velocity. I don't know if you have seen that situation or you've observed people who are playing snooker. Just sit down and watch them, or maybe you could watch a video, you'll see how this works. Okay, now maybe you have seen an accident before, okay, a situation where there's a car crash. Are you here? Okay, now in inelastic collision, the kinetic energy is not maintained because some of it is lost in the form of what? Heat and sound. Some of the energy is what? Lost in the form of heat and sound. And that's when you get, when you are where there's a car crash, you hear "Bwah!" Okay, and then okay, you hear sound, and then if you are close to the car, if you kind of feel the area where the impact is, you will feel that the place is kind of what? Hot. Okay, now, but that's the by the way. Now what we have the situation where these two balls are facing each other. Okay, they are not moving in the same direction. Okay, they are moving in the opposite direction. Okay, we have something like this. If the two balls are moving in the same direction, let's say this is a snooker ball, it means they'll be facing each other. Okay, this one is moving this way, this one is moving this way. Okay, just imagine you watching me, you are coming like this and me, I'm coming like this. It's not the same direction. If it's the same direction, we should all face this way. Are you here? So now if you have this situation, okay, now after collision, this is before collision. Before collision, let's call this body A and this body B. All right, of course this one is having its velocity, let's call it VA. This one is also having its velocity, let's call it VB. All right, the rule is still the same. What is the momentum before collision? The momentum is simply the product of mass and velocity. So we have m of A, the mass, velocity, okay, then plus what? M of B, and then V of B. This is the momentum before collision. So, but please take note, because they are moving in opposite direction, not in the same direction. Okay, we use negative sign to denote opposite direction. So here is no longer going to be what? A plus. It's going to be what? A minus. A minus. Okay, so now if after collision we have something like this, after collision, the two bodies, if they stick together and move in the same direction, the momentum after collision is going to be, after collision is going to be M A, this is A, this is B, mAvA plus mBvB. So we equate this to this is equal to this. Momentum before collision is equal to momentum after collision. Okay, now let's talk about a body hitting on a stationary body. A body hitting on a stationary body. Okay, let's say this is a stationary body. Body B is stationary, and this one is the one that is going to be in motion. This one is a stationary body like a rock. Then we have this body A. What is the momentum before collision? So we have before collision. Oh, sorry. We have what? mAvA. This is going to be plus MA times 0. Why? Because this is a stationary body. It has no velocity. There's no velocity. Its velocity is equal to 0. Are you here? So this means that for before collision is simply mAvA, and then after collision, okay, where this body comes and hits the rock. Are you feeling? This is body A and this is body B. We have mAvA plus mAvB. This is after collision. This is before collision. So we have this is equal to this. Okay? So now let's quickly solve a simple problem. It's getting dark. I would have loved to solve more than one. Maybe in the next class we'll be solving more problems on collision. Okay, but let's take this simple problem. It says two moving toys of masses Alright, two moving toys. Sorry, let me take chalk. Two moving toys of masses 50 kg and 30 kg are traveling on the same plane. Okay? Okay, let's say this is my toy. Pardon me, I don't know how to draw. Let's say this is the toy. Okay? Two toys. It's two toys. This is another toy of masses 50 kg and 30 kg. So this is 50 kg, this is 30 kg. Okay, I don't know why I like A and B. You can decide to use anything. You can use X and Y, C and D. Which other one? E and F. It must not be A and B. I love simplicity, so I'll still go with body A, body B. Okay, and traveling on the same plane with speed of 5 meters per second. Please, momentum, I hope you know momentum is a vector. Momentum is a vector, and you know what vectors are. They have both magnitude and direction. Okay, it's important that you include this. Now we have a traveling on the same plane with speed of 5 meters per second and 3 meters per second. So if this is traveling at the rate of 5 meters per second and this one is traveling at the rate of 3 meters per second, okay, respectively. You know what respectively stands for, right? It means the first number given is for the first object and the second number is for the second object. All right, if they collide and stick together, okay, if they collide, so let's treat before collision. This is before collision. So this is before collision. So after collision, they see this, they spoke. What's the past tense of stick? Let me maintain stick. They stick together. So these two cars, they stuck together after collision. Okay, after collision. Of course, the mass is still the same. We have 50 kg. We have 30 kg. The velocity is still 5 meters per second. If they collide and stick together, we're not giving the velocity. Of course, we know what the velocity is going to be. It's going to be a common velocity. If they stick together, it means the velocity will be the same. If it's not the same, one should be in front and the other should be at the back. But if they are together, it means the velocity is the same. Okay? So if the first one is moving with 5, the other one too is moving with 5. If the first one is moving with 10, it means the second one also is moving at the rate of 10 meters per second. So if they are sticking together, it means they have what? A common velocity. So let's say the common velocity is V. The common velocity is V. So if the common velocity is V, okay, V, let's say this one is V, this one too is V. Okay, so this is for after collision. After collision. Now let's write down the formula. We don't joke with formulas in physics. It is important you write the formula. So we are going to write down the formula, and the formula can easily be derived from what you have drawn. But please remember that momentum is simply the product of mass and velocity, and that is what we are going to be using. So it's going to be mv, 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 mv. Okay? mv, 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 mv. Alright? But what you will do with the mv is what will determine if you are going to arrive at the right answer. So let's go. So of course, since this is moving, they are moving in the same direction, we are going to have a positive here. Suppose they are moving as in facing each other face to face, of course it's going to be a minus. But since they are moving in the same direction, we are going to have a plus. So it means the momentum of A plus the momentum of B is equal to what? The momentum of A after collision plus the momentum of B after collision. What is momentum? Mass times velocity. So we have what? mAVA plus what? mBVB is equal to what? mAVA plus what? No, I'm wrong. Pardon me. MB this, we have B, and then we have VB. Okay, now what is MA? Let's come back to our diagram. The mass of A is 50 times the velocity of A is 5 plus the mass of B is what? 30 times the velocity of B is what? 3 is equal to the mass of B. The mass of B is 50 times what? V. I told you let the common velocity be V. They spoke together. I don't know if that English is correct. Please, if it's not, pardon me. So we have 50 times V plus 30 times V. Okay? So we have 50 times 5 will give us what? 250 plus 30 times 3 will give us what? 90 is equal to 50 times V. 50 times V will give us 50V plus 30 times V will give us what? 30V. Okay. Now, 250 plus 90 will give us 340. 340 is equal to 50V plus 30V. 50V plus 30V will give us what? 80V. We are looking for V. We are looking for V. Calculate their common velocity. Like I said, let V be the common velocity. So we have V. Okay? If we divide both sides by 80, we divide this side by 80, divide this side by 80. 80 we cancel 80, and then we are left with V. So we have 340 all over 80. This we cancel this. 34 divided by 80 will give us 4.05 meters per second. Okay, we'll stop here because it's already getting dark here. I didn't start today's video on time, so we'll stop here. Maybe in the next video we'll be treating more examples, okay, that will help your understanding of solving problems on conservation of linear momentum. I hope you enjoyed today's class. If you did, please like, subscribe, and share. I'm still Bukola Joseph. Thank you for your time.